Hello, everyone. Good afternoon and good morning, depending on where you are logging from. This is our second talk on introduction to Eclipse. In this tutorial, we'll be focusing on debugging parallel code. In the previous code, we showed how to use the Eclipse to develop a code and debug simple C, C++, and the Fortran code. Here's the arrangement of this tutorial. I probably going to spend a quarter of the time just talking about the facts, the information about the Eclipse, and some important things to know, and where to look for information, and where to get Eclipse, download it, and install. And then I will spend the rest of the time on a demo showing you how to write the code, how to create the projects and develop a code, and debugging a parallel code. I'm probably going to go through 5 or 6 examples, serial, and MPI parallel examples. Okay, so about the Eclipse. So what is Eclipse? It is an IDE, or integrated desktop environment for development and the debugging. It supports C, C++, Fortran, and many other languages, including Java, Python, PHP, and other things. And also it supports debugging MPI and threaded job with the OpenMP and the pthreads, and many other features. And it runs on your local computer primarily, and on remote systems as well. But we're not going to be talking about using Eclipse on a remote system. And what Eclipse is not, it is a front-end user interface with an editor and a code analyzer for C, C++, Fortran, and MPI and other languages, and to the underlying compilers and debuggers. It does not come with compilers, debuggers, and memory analyzers, and the schedulers. So in other words, in order to use the full feature of Eclipse, you would have to have the compilers and debuggers installed first. And why Eclipse? And debugging parallel code is not straightforward, as we know. For those of you have developed parallel code in threaded code or MPI code. And there's some options for debugging a parallel code. For example, the MPI code, DDT, which is the #1 tool we recommended on clusters across Compute Ontario. Compute Canada Federation high performance supercomputing systems. And TotalView, we used to have it, and it is still widely used at many other HPC centers around the world. And these two are not free. They cost a lot, and it is meant to be for institutions, not individuals, to have them. And the GDB is free. The GNU debugger is free. It is a command line based. Because it is a command line based, it's hard to use, especially when you want to debug a parallel code. So you don't have a global view of the running processes or threads. And Eclipse is one. It looks like the Eclipse is the one of the viable options. It is a free and is GUI based, and it is reasonably intuitive to use. And there might be some other options out there. Eclipse, where to find Eclipse? Let me just switch to Eclipse, the website. If you go Google it, Eclipse, eclipse.org, and /downloads/packages, and you will see, you will actually see this page. On this page, there's a list of packages for different languages and purposes. And in particular, for parallel computing, you want to scroll down to near the end, the Eclipse IDE for scientific computing. And this is the tool set for C, C++, Fortran, UPC, and many others. A parallel debugger, and it can remotely building, running, and monitoring applications. So it has more. It's not just a debugger. It can do a lot more. So we click that. You click that, and you come to this secondary page specifically for this package, Eclipse IDE for scientific computing. So Eclipse is a name. And under this name, it has many separate packages that you want to pick and choose the one you want to use. So we picked the IDE for scientific computing. And then on the right-hand side, download links. If you want to click, you want to choose the operating system you want to use, Windows, Mac OS, or Linux. In this case, Linux, for example. If you click that, now, then you can go download. Okay, and you can download the software. Okay, so this is Eclipse. Where to look, where to find the download sources. Now back here. So requirements for Windows. If you are Windows users and you wanna use the Eclipse for Windows, and if you are sophisticated enough, and you can download, you can install compilers, debuggers for Windows. For example, in this case, you want to find a SIGWin distribution. SIGWin is an emulated Linux environment running on top of running inside of Windows. It is not a virtual machine. It's just a collection of a whole bunch of applications running on Windows, emulating a Linux environment. It has a full set of component features, compilers, debuggers, libraries, everything. Okay, so that's the one of the routes, and the other is what we recommended. You wanna use the Windows subsystem for Linux, and this is made by Microsoft. Yes, Microsoft has made Windows subsystems for Linux available for people who want to run native Linux on top of a Windows. Okay, and you can see the tutorial on SharkNet on the YouTube in the YouTube channel by going to youtube.sharknet.ca and to find how to enable Windows subsystems for Windows, especially for Windows 10. It comes with the Windows from Microsoft, so it is a native product. And once you have the WSL enabled, then you can install whatever the Linux flavor you like, whether it's Ubuntu, Debian, or CentOS, or anything that's supported. Okay. And the Linux, Eclipse has distributions for Windows, Linux, and Mac OS. So for Linux, you want to install compilers, GNU compilers first, and the GDB, and the Make, CMake, and MPI, MPI libraries. And if you want, optionally, you can install Intel compilers and any other flavors of MPI or any other tools. But in this tutorial, we're gonna just stick with the GNU tools. For Mac OS, I'm gonna skip that, and the GCC compilers, the makefiles, and the libraries is all available for Mac OS as well. Okay, so for both the Windows using WSL and the Linux, we're gonna just stay with Linux. The examples will be focusing on Linux examples throughout this tutorial. So, okay, if you have any questions or you want to learn details, if you missed anything I talk, then you can always go to the YouTube channel to find the relevant tutorials and the recording of this session later on this week. Okay. Next, it is always recommended, this is what we always tell researchers, our users, to install an MPI implementation on your own machine. So you can practice, you can have immediate access, and you can practice the development code. And it is recommended on Linux and Mac OS to install OpenMPI or MPIS. And for Windows, I just mentioned that we recommended to enable Windows subsystem for Linux and install the Linux on top of it. And then here you go. Okay. So the scope of the tutorial. So what are covered and what are not. We will be covering Eclipse on Linux, as I said, and we will demonstrate the C++ and the Fortran code and the MPI code. And we will not cover threaded code, MPI code, using an OpenACC for accelerators. And we're not going to be covering non-GCC compilers like Intel compilers or CLAN compilers or any other compilers. And we will not be showing you on how to running and debugging code on remote systems. And we're not going to be talking about the use of a Git, which is also available with the Eclipse, and these will be the following up tutorials, or you can find relevant tutorials, recorded tutorials on our SharkNet YouTube channel. Okay, so development and debugging. Let me just go to Eclipse. Okay, let me just close the Eclipse and start over again. So once you installed, let me show you a little bit more. Let's go to downloads. So I have Eclipse downloaded, and once you go to Eclipse website and select the scientific computing tool, and you will have this tar file. Download the parallel at 2021 606 and -R release. Okay, so what I'll do is to untar this file. Once I type the command, and a directory called Eclipse will be created, and inside this directory or folder, there is an executable Eclipse. You can simply just type /. I put a dot in front, // in front, just in case that my current directory // is not in the search path, and then the name. So I can start Eclipse in this way. Okay, if it's installed in your in user space. Now, in my case, I installed it in different place, and I added it to the GUI, the desktop under development, and I just click Eclipse IDE. It starts up. It asks you to where your workspace should be created. I just choose my document Eclipse-workspace and click launch. And it will come up in a few seconds. Now, here we go. So this is the first interface you will see. On the left-hand side, that's a list of projects. I'll come to that. And here in the middle, the top, this will be your editor area. And on the right-hand side, there will be some useful area for later on for debugging, for tracing the purposes. And here at the bottom, it has a couple of tabs. One of them is a console. This is the place when you run Eclipse, it will show the information. The information will show up here. Okay, so the first example, I'm going to create a project. Let's say I don't have anything, and we're just going to create a project from scratch. So I go to files, although I have a list of projects, pretending I don't have it. And I'm going to just walk you through the procedure of creating a project. So this is the concept of many IDEs. Everything is a project-based. You create a project which corresponds to a folder, an inside folder. There's some subfolders and the files. That's where you put your source files and executables and debugging files. So here, the first thing first is to create a project. So you go to new, and there are a number of options. C project, synchronized project. This is specifically for MPI to sync between local and the remote. Let's not worry about that. And a project which gives you more options. So let's just create a project. Click that. And click that, and in this dialog window, we have a couple of options, C++ and the Fortran. And under C++, I have a couple of options, C++, C++ project, the C project. Let me just create the C project. Click next. Okay, so next, whether you want to create an empty project or have some other things, you have an option. Hello World, the C project is a template. You're creating a project from a template, and then you will get the example. Or I can just create an empty project, or you can create an MPI project. And I choose the empty project because I don't have anything. And on the right-hand side, under tool chains, you want to select Linux GCC compiler, because I don't have a cross compiler. I don't have an Intel compiler. So the GCC compiler. I click a GCC compiler. I give the project a name. Let's call it C hello. I just give it. I already have a C hello. I just give it a different name, hello 1, and then click finish. Okay, so I got nothing, but a project has been created. I click that, and it has an includes folder created and nothing else. Now, what I'm gonna do, I'm gonna create a folder, a new folder, source folder. This is a typical arrangement. I got the SRC. Okay, and inside SRC, I want to create a new file, because I don't have any file. I want to create a new source file. Source file here, source file. And the source file, let's just call it the main.c. Okay, call it main.c and finish. Okay, I've got nothing here. So let's just start, create a file and include standard io.sh, and then include standard lib.sh, and I want to create an extern. I want to create a prototype of a name, a function routine. It's got hello, and which passes in a string. And then this is my main program. And in the main program, I'm doing nothing but just call this routine hello with a string hello world. Okay. And then return, because this main program returns the integer. So return success. Okay. All right. So I have my main program, and But I don't have this file. I don't have this routine yet. So I need to create a routine. So going here, I create another file. So basically, I'm creating two files, and the source file, and let's call this. Just call it hello.c. It opens up a source file, and this is a void hello, which is a string message, and simply just print this message. Okay, that's it. This is the function, and it's printf. So I need to include std.io. Okay, so I save this file, and also I need to save this file, and then I just simply click build. Okay, so in a fraction of a second, it built. It has built, and the target, the executable is called whatever. It's called a c-hello1. But let's not worry about the exact name executable. All we need to see is to see if we can run it. And here's the button to run it. Let's run it. And it says it's a local. This is the reason that it prompts me for this, whether it's a local or not, because I installed this package for scientific computing, and this is for parallel development and the debugging. So that's why it asked me whether it's a local or remote. So I click OK. Okay, so it ran. It runs. This is exactly what we expected. So now this example, the first example, I created a project, and then I create the main file. And in the main file, I define a prototype of a function, which is defined in another file I created called hello.c, hello.c here. So I put the two source files there, and then I just click this hammer to build, and the Eclipse, the development development tool is called the C++ development tool, CDT, and takes care of creating a makefile and the building the executable for you. We'll come to the details later on. Okay, so this is just the example. We create a project on the fly and create a source file and create another source file. And one is a main file, and the other is the file that contains the subroutine. And then we simply just click the hammer to build the project, and then click the play button to run the project. Okay, so that's our first example. Now the second example, I already have the second example prepared. So I just let me just close the first example, close all editors, and open the second example, C overflow. Let's see how we debug code. So this is a C example that contains a bug. It's a bug. It's not a language bug. It's the bug that violates the integer operations out of a range. Okay, so very simple program. It's a main program. It calculates the factorial of a given integer. So in this case, we have a routine called a factorial. This factorial is just given an integer, it calculates the factorial and the returns. And in the main program, we tested. We're testing two cases. One is when n equals 5, and the second when n is 13. Now, we know that the factorials increases the number, the value increases very rapidly. For example, if you ever do this, this shows the factorials of corresponding numbers. 1 is 1 2 2, and the 5 is 120, and the 13 is 32. Sorry, it's 6 billion something. Okay, it increases rapidly. Okay. So now here, we're gonna just go over building a debugger version. Now let's take a look at this closely. If you click this drop-down menu, hold it, it shows there are 2 options. One is debug and second is release. By default, it is debug, okay? And let's take a look at how a debugging version is created. So how to see this? You want to go to a project, go to project, go to project and property. This property corresponds to this project. Okay, different project will have different properties. So this is not a global setting. So then we see there's a couple of options here. Since this is a C++ project, we want to click C++ build underneath. You click a settings. You click a settings, and you see the compiler. This is where you specify compiler, and this is where you specify the options. These options are preset. Now you can move the cursors. You can move cursors, but you cannot add anything. You cannot add anything there. If you want to add any customized compiler options, you want to go either dialect. For example, you want to select the language standard, whether it's a C99 or C11, or you want to include something, or you want miscellaneous. This is where you can add your. This is where you can add your options. Okay, I'm not going to do that. I just want to show you. Go back to compilers. So it's a GCC compiler and the GCC linker. Why is a linker? The compilation has 2 stages. One is compile to generate the object files, and then the second is to link all the object files along with a library, a link against the libraries, and to generate executables. So the linker is also GCC. This is correct. We don't have to worry about the sampler. So this is the build. This is the settings for the compiler. Okay. If you go back to compiler, you will see the options. This is -0 and -G3. This, in other words, these options -G3 means we're compiling this code to for debugging purpose. Use a -G option for debugging purpose. Okay, so this is already at the properties. So we're not gonna because since we haven't made any changes, I just cancel. And the next, we want to go to run options, and then you want to see how you going to run it. Run as a release, as a normal application, or you want to run the application as a in a debug mode. So let's click debug configuration. Now in the debug configuration, for C, C++ or other language, you will create a debug view. This is called in the Eclipse. A term is called perspective. So this is already created. We call it C hello 1. Okay, by default. Sorry, we're looking at a C overflow. Sorry, C overflow. This is what we are looking at. C overflow. We want to debug C overflow. Okay, so C overflow, and the next you want to see. This is a project, the C overflow, and the application is to run in the debug folder C overflow. Okay, you can choose by browsing the content, the files. And then you click a debugger. Now the debugger, it is already a field to use a GDB. If it's not a GDB, this is where you can change, but we're using GDB. You don't worry about the rest of the options, just keep it as is, and then you can close. Now, we wanna build, so let's click a build. Nothing to build because it's already built. So you can go to clean, go to project and clean. I want to clean C overview and the clean, and then want to build. Go back here to build. Okay, it's done. And the executable is got a C-overflow. So we have this already built. The next, and we're going to go run debug. Here's a bug, the icon. You click this drop down menu option. Then you want to pick. Okay, that's a C hello world, and then we don't have that one. We better just create a debug configuration, and want this guy here, and then the debug. Okay. So now we are in the debug view, or kind of debug perspective. You see that it has changed, and the hammer icons disappear because this is in the debug perspective. You can switch between the editor mode and the debug mode by clicking these two icons on the rightmost. Okay, so we're now in the debug mode. Now the debug mode, on the right-hand side, there are a couple of options here. The first is the variable. Okay, the variables. It is the variables here. So since we're in right now, we're in main, and main there are only two variables, and a fact. Okay, and a fact, and this is factorial. And then we wanna set a breakpoint. This is a term. This is a debugging or a GDB term. We want to set a breakpoint at which we can step into the code and stop. Okay, so you can double click to set a breakpoint. The double click this 18. This is line 18. Okay, so we set a breakpoint here, and so that we can watch the value, and then we can stop here, and we can step into this function, and then you click the. You can also click this tab here. Breakpoint is already, you see, line 18 is already set. So you right click, and then you choose breakpoint properties. It tells you what to do. You can do about this. So we want to click common. So what we want to do at the line number 18, and we want to put the condition here. So we want to put a condition when F when F is greater than a certain number. Let's say the largest small integer, that's a 32,767. Okay, so this is the condition. So when we run the debugger, when we step into the source code, and it will go until this condition becomes true. Okay, so let's apply and close. And then we set a breakpoint, and we set the watch point, we set the condition, and then we can click go to resume go. Okay, so then if you go back to the variables here, it shows when the F is greater than 32,000, and It stopped. It stopped where? Where does it stop? Let's see, go back here. This is this debug window, and it contains the call stack. If we click main, this is our current, this is the call stack. It shows it stopped right here. Now, in this, to pay attention to this main program, we have two calls to Factorial. We passed the first tutorial. We passed the first call, even though we set the breakpoint here, but it didn't stop the first call, but it did stop at the second call. Okay, because we added a condition. We add a condition that to tell the debugger to stop when f is greater than 32,767. Okay. Let's let it go. Keep continue. 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 It stopped. So it's done. So we have two answers. Here, 5 factorial is 120, and 13 factorial is this. Is this correct? No, this is not. And this is why we're debugging here. See, when 13, as we saw, it should be 6 billion, but it is, as a matter of fact, it's not. So this is just a quick example. It shows you how you can trace your source code on a specific variable and by values. Okay. This is the second example. Let's go back to this view. Make sure we close this one. We close the project. We close. Sorry, we want to close this project. Can I close the project? Close project. Oh, no, clean project. Close project. Close project. And this one, I want to close project too. Close project. Okay. So let's look at a third example. Our third example is a C++ code. And the C++ code and the source code, again, is in the folder source. And let's open it and see what's inside. Now, let's not worry about these lines of the code, the source code. Let's just simply jump to the very end, the main program. The main program contains only 3 lines here, okay? 3 lines here, and it does nothing, but it just prints a string. Prints a string, hello world. Okay, now let's see how we're gonna debug this code, okay? Since I already said, let's see, I want to debug, let's just build. Oh, nothing, let's just clean and build again. Build again, okay, so we're ready to go. So we click the debug, we click the debug icon, and we come to the debug mode or debug perspective, and make sure that we are in the right example, right project. Since we already closed all the other projects, this is the only project open, which is CPP trim. This is what we have. Now, the program stops right here, the very first executable line. Okay, it hasn't started yet. So now we're gonna go step into that. That's the common operations using a GDB. You're gonna step into the code, or step in, a single step. So let's go to step into, and then, okay, so it goes to the next line, and step into, it jumps to the function it calls to trim, and the step into, and step into, and step into, and it goes a whole bunch of things that we do not recognize. This is not my code. This is not my code. If you want to do that again, how do I, what happens? How come I step into someone else's home? So this is because the GDB by default will just go when you click when you step into a single step into it, will just step as far as it can go. Okay, it step into every single function on the call stack. Now, what if you don't want to step into irrelevant sources? You want to only focus on your own your own code. So there is a way of doing that. The way of doing that is by looking at, let's go take a look at the configuration of a debugging. You click a run, and then you click a debug configuration, and then you click debugger. Now, the debugger shows it is using GDB, and also the GDB reads a file, and this file .gdb init, this file regulates, sets what GDB, sets the behavior and defines what the GDB should do. Okay, now let's take a look at this file. This is what this file, where is this file? This file in my home directory. And let me just go back to command line and go to my home directory, and let's take a look at the content of this file. And that's a GDB init. Oh, that's nothing there. Nothing there means the GDB by default, since I haven't set any my own rules, the GDB will behave by its own default behavior. Okay, so if I want to change, if I want to restrict the behavior, so what I'll do, I'll add some lines to this file. Let's add some lines. Because I already have a file created. So let me just run over GDB and let's see what I put inside. So I put inside a few lines here. Let me open it just so it's easier to see. So basically I put 2 lines here. You can add more lines, and these 2 lines, it tells the GDB to skip any tokens that in the source code or inline files, and it started with the std, and it started with the dash underscore. You can add other rules. So then the GDB won't go inside those areas. Okay, let's see what happens by adding these after I add these 2 lines. Okay, so I'm not going to change anything since I put this already put this thing here. Now, if you installed Eclipse and the GDB, what you will see in this command line box is .gdb init. Okay, and I put this file in my home directory. Okay, so it's close, save to this. I don't save, and then I want to make sure I have that back configuration and debugger. Yes, I have this new file. The rules I defined myself, and then I close, and then I start a debugging. Okay, so I just click the debug. Oh, sorry. Before I do that, I need. Okay. So I start a new debug session by clicking the bug. Okay, and then I step in. Now this time it doesn't go into those crazy unrecognized places. Okay, so this is a trick. This is a GDB specific thing. Okay, so let me just summarize this by putting a slide up here. So you to restrict, to specify the GDB, how GDB should behave, you can put the lines or rules in the GDB in it. In this example, I put these rules. I'm going to skip STD, skip things start with TR, skip things start with the header file, the POSIX, and a skip a boost, skip a CV, and so on and so forth. Okay, and this is about the GDB and avoid stepping into other areas. And back. Okay. So next, I'm gonna quickly show how to run the MPI program. Okay. Let's go back. Let's stop this. Stop and clean, and then go back to the editor view. And I want to close this project. Just make it clean. Close this project and go inside MPI project. I have an MPI project, MPI hello. And inside the folder, I have this project. Just quick. Okay, so this is an MPI code. This is an MPI code in C. This MPI code is very simple. What this MPI code does is, if the rank is not zero, non-zero, and the process will create a message as a hello world from process ID, and then send this message to rank 0 or the root. And if the rank is root or 0, basically it will be sitting in a loop and receive messages from whichever process that arrives first, and it prints this message and it goes to the next. Okay, very simple program. Let's see how we're going to build and run this program first, and then let's see how we're going to build and debug this program. Okay, so for the MPI code, you can simply also, because this is created as the MPI code, and if you go to a project and project properties, this is you can see how the MPI code or how the compiler is being chosen. You click a CC++ build and then click a settings, and you will see in this case the compiler is MPI CC, and this is where to put the compilers for MPI. So in this case, the difference between a regular CC++ code or Fortran code and an MPI code is simply the compiler, which is instead of a GCC, but the MPI CC, which is the compiler for MPI. Okay, and the linker is also MPI CC. Okay, so this is how we specify the compilers for MPI code. So I'm not going to change anything, so cancel and go to run. So that's how we're going to run this MPI code. Now let's not worry about the debug configuration first. Let's take a look at the run configuration. We want to run this code. How do we going to run this? Because the MPI code, we're going to use multiple processes. So we need to tell the MPI how many processes I want to run and how I'm going to run it. So click a run configuration, and the dialog window pops up, and it says, "We'll run a command on the target system local. Do you want to continue?" Yes. I don't want to ask me this again. Just yes. Okay. Just wait for a bit until this dialog window comes up. Now, again, this time you should choose MPI applications. If you click MPI application, if the run configuration is not create it, and the first time it will create it for you. And this is the project that I already created. And so the run configuration MPI hello is already there. And the first thing you want to do is you want to choose the target configuration. You click this drop-down menu. There's so many options. You can run local, you can run a PBS, you can run Slurm. And let's not worry about any of those. I just want to run MPI code on my local machine. So I click a generic MPI, Open MPI Interactive. Click that. Once you click that, you click a local. You click a local, and you let me just do this again. So let's pick anything first, and then jump back. Say yes. Oh no, because I don't have that. Now, let's say I want to select the very first time there's nothing there. It will prompt you to select an option. So I want to select generic Open MPI Interactive so that I can run this on a local system. It says yes. Okay. Now you click a local, and then this is where you put the number of processes. Now I click the number of processes 10, be 10, and then I want to run. Boom. It says there are not enough slots available on the system to satisfy 10 slots required for running this program. What does that mean? So my computer only has 4 cores, and I'm trying to run 10 processes. And in MPI, Open MPI world, this is not allowed. So how do we do that? How can I run 10 processes on a system that has only fewer than 10 processes? This is what we do. And go to run, and then go to configuration. Oh, yes. And then go back here. Now, you want to use the host file. Click a host file. Click a host file. I already have a host file there. The host file, I put the host file in a folder, in this folder. If you look at the left-hand side, just apply and the close. And then this is the host file. If I click, open this host file. This host file contains one line. It says, I'm going to use the local host, and each host, I will have 16 slots available. I'm cheating. I don't have 16 cores, but I can specify whatever the number of slots available, 16. So now I can run the program with 10 processes. Okay, go back here and go to run, and then I just click a run because I already configured how to run it, and click a run. And this is a local application. It says okay, and wait a bit. Because I'm running it in a debug mode. But anyway, if I don't set the debug, that should continue. But anyway, because I've already set the breakpoint, it won't continue for the regular run. So let me go to the next example. Still the same code, but show you how to run it in the debug mode. Okay, so let's go to run and debug configuration. This is for parallel, and this is parallel. Hello. Still, this is the way to run. I'm going to run the 10 processes, maybe too much. And let's say 4. Okay, and debugger, and the debugger is using GDB-MI, and this is already preset by default. and then you need to select the application, what you want to run. And this is by default, I want to run the MPI code I just built. It's called the MPI hello. Okay, so you can close, and you want to save. You don't save. I haven't made any changes. So I go to I click the bug icon, and I click one of the options. That's the MPI hello. Okay, and then then it tells me it's going to go into parallel debugging perspective. Yes. Okay. Okay. I'm using the old configuration because I didn't save. The old debugging configuration, I'm still using a 10 processing. Now, there are two areas. One is the parallel debug, which gives you the global view of processes, and then the individual debug area, which is contains the processes that are registered so far. Only the first one is registered, which is process 0. Now, if you double click the second one is being registered. By register means it's being added to the individual debug list. And then you can do the same thing. Do the same thing for all of them. So I register every single one. So all of them are now registered. So I have process 0 to process 9 registered. Okay. Okay. So next, breakpoint. And we set a few breakpoints here, right here, and one here. Now, what we are more interested in here is the variable. We want to see the variable list here. And what we want to see, how, for example, the rank P changes, that's the value, and the message changes. If you click the message, because message itself is array, it shows individual element, the values of the element. Okay, so let's go here. This is a parallel debug. Let's step over, click a step over. Step over, come to the init. So everyone is running. Everyone is running. And next, we'll come to the next line. And then come to the next line. And then we'll come to the next line. You see these, the variables here, the values keep changing. If we click on any of them, nothing. Let's go. Let's say I want to go in particular, if my rank is not 0, let's go to process 1, click a process 1. And then we want to go here because the process 1 has been suspended. Let's resume. It's running. Process 1's running, and everything else want to resume. Oh, it's terminated. So the final result here is 10 messages of hello world coming from different processes. Okay. Now everything is terminated. Let's just let's start over again. everything is terminated. Let's clean up, and let's do it again. Okay, and click, click, click to register all of them. Okay. And then we just run step over. And then we can examine messages. Sometimes we can see it, sometimes we don't. Not yet. Let's see, we want to go to suspended process one. Process one, step over. Step over. Step over. Step over. Okay, now you see, I stepped into process one and I see the result, and I will see how the message, the values of each this array message changes. So you can select the other process as well. And also the Eclipse, this interface also gives you an option to select a set of a process. Instead of having all the processes, you can group them. You can select, let's see which one. Okay, let's just take. Let's just keep the first 5. And let's give a name. So set 1, let's call it set 1. Okay, so here, set 1, I only keep the, I only include the 1. Let me just go back to root. I want to click, I want to add them to a set. Add them to set 1. Oh, sorry, control click, yes. And add to set 1. Now, I'm just adding, now I have only 5. I can only, I can look at 5 of them. So instead of debugging, instead of having all 10 involved, I'm only looking at 5. So that gives you an option. You can define different sets, set 1, set 2, whatever set, and the debugging the MPI processes within the sets you you define. Yeah, I think I covered the serial and the MPI code. And the last thing I want to just quickly mention is the Fortran code. Okay, let me just go back to it. First, let me stop. Let's go back. Well, okay, let me just kill it. Kill restart it. Because I finished a debugging demo. Let me just show you a last example. Go to development, Eclipse. This is the leftover. I want to switch to the editor view, and then I want to close all the project, close all editors, and also want to close the projects. Sorry, close project, close project. Okay, everything's closed. Now, to create a Fortran project, so you go to a new and go to project. Now you don't go to the Fortran project. You can click Fortran project, but I'm showing you how you can create a project using C++ project. And go to project, and let's say it's a C manager to build, and then let's call it Fortran project, and then here that's an empty project, and then I click a GCC, okay, and I finish. Now I have a new project, and there's nothing in it, and then by the same thing, I'm gonna create a folder, create a source folder. Let's just call it source folder, and then in the source folder, you want to put the Fortran code. Let's say you want to create a Fortran code, the source file, and the source file. Let's say just call it hello Fortran. Let's not worry about that. And just finish. So opened up, and that of course this is not a Fortran style. Let's delete it, and let's say program hello, and the print hello world. Okay, so that's the source code. Now let's go to project properties, and let's select the compilers. Now this time you want to go to since this project is specific to the setting is specific to this project, let's go to C++ build and the settings. And then you want to click the to chain editor first. And there's nothing here. And you want to go to selector tools. And then you click Fortran compiler. The Fortran compiler is here. Oops. You want to select the Fortran compiler. You want to add to the tool chain. Fortran linker. I don't have to worry about that. The Fortran compiler is already there, and I click OK. Okay, and then you go to settings, and then you simply just change the GCC to G-Fortran, and the GCC linker, you change that to G-Fortran, and the G compiler is already Fortran. Okay, then you apply and close, and then you do compile. Oh, I haven't saved. And the compile again. Okay, it doesn't like 08. It doesn't like an 08, and let's just rename it. Rename it as Fortran 90. Fortran 90. And build again. And that should be end program. And end build. Oh, yeah, that is an artifact. Every time when you make some changes, you have to save and then build. It's done. Then you can simply click and run. should see local Fortran applications. Hello, whoa. So that's it. So I covered all the demo. Sorry, I just ran a little bit over time. And let me get back here, just give you a final summary, develop and debugging. Okay, so creating Fortran project, some thumb, create a C++ project. If you don't have the Fortran interface available, and create everything as a C++, and then you just select the Fortran chain rules and compiler, and then select the compiler and then build and run as usual. Okay. Having multiple files already showed that you can put multiple files in the same directory, and the build, the Eclipse build mechanism will take care of that automatically. So I just stop here, just in case there are any questions.